Okay, so this is going to be the video for Chapter 8, Lesson 2. Just going to briefly go through what we covered in this lesson. Really only had two new things in this lesson. If you have something like x to the y, then x is your base and y is your exponent. And if you have x to the a and you multiply it by x to the b, what you have is x to the a plus b. So if you multiply two numbers that have exponents, as long as the two numbers have the same base, then all you have to do is add the exponents. So if you have x squared times x cubed, that is going to be x to the 2 plus 3, which is x to the 5th. So just to show you an example from number 4, which is just like number 11 on your homework. For number 4, if we look at let's look at part D. You can see that we have 1, 2, 3, 4, 5, 6 x's. We have 1, 2, 3, 4, 5, 6 x's, and then a y. That means this is x to the 6th times y. And in part E, we have x times y times x times y times x times x. If you look at that, we have 1, 2, 3, 4 x's, so that is x to the 4th. And then we have 1, 2 y's, so y squared. So that's just how you would do, this is number 4, which is just like number 11. Now for number 5, it says multiply as indicated and express your answers in exponential form. This is just like number 12. So if you have a part like 5b, where we have y times y to the 9th, remember if there is no power listed, it's an understood power of 1 because obviously we have one y there or nothing would be there. So we add our exponents, y to the 1 plus 9. So this is y to the 10th. Do not use a 0 here. This is y to the 1st power. Then if we have something like part G, 2x squared times 8x to the 8th, what we can do is multiply our numbers together. We have 2 times 8. So that's going to be 16. And then we can multiply our x's that have exponents. So we have x squared times x to the 8th. That is multiplying two numbers with exponents. So that's going to be x to the 2 plus 8 because it's a power of 2 and a power of 8. So that is 16x to the 10th. Again, number 5 is just like number 12 in the homework. Okay, moving on to number 6. Find x in each of the following equations. I'm going to give us a new page for that, and I'm just going to do a couple of these. So, like 6a is 10 cubed times 10 to the 8th is equal to 10 to the x. But we're multiplying two numbers that have the same base, so we can write that as 10 to the 3 plus 8. We add our exponents, and that is 10 to the 11th. And we know that that has to equal 10 to the x, so our x must be equal to 11. Another one is like part D, 6D. We have y to the 1 times y to the 7 equals y to the x. Again, we're multiplying two numbers with the exponents. They have the same base, so that means we can add the exponents. Y to the 1 plus 7 is equal to y to the 8, which is the same as y to the x. So x must be equal to 8. Let's do another one. We have, well, here's a different one, number 6g. Y to the x times y to the 10 is equal to y to the 30. Multiplying two numbers with the same base, so we copy down the base and we add our exponents, x plus 10, and that has to equal y to the 30. So that means x plus 10 must be equal to 30. X plus 10 equals 30. And that means that our x is 20. Okay, one more that we will do. New page. Let's do 6h. We have y to the x times y to the x is equal to y to the 16. Multiplying two numbers with the same base, that means we add our exponents. So we have y to the x plus x. And that's the same as y to the 2x, because we have two x's there, which equals y to the 16th. So 2x must be equal to 16. And that means that x must be 8, because 2 times 8 is 16. Okay, remember, number 6 is just like number 13. Okay, the next thing we're going to look at is number 7. Number 7 is just like number 14, and it uses one of those table of powers. So it uses a table of powers of 3. So just for an example, 7a, we have 3 cubed times 3 to the 4th. Multiplying two numbers with exponents that have the same base. That means we copy down our base and we add our exponents, 3 to the 3 plus 4. That is 3 to the 7th. And then we look in that table of powers that's just to the right of the problem, and we see that 3 to the 7th is 2,187. Skipping down a little bit, well, we'll do 7b. We have 3 times 3 to the 10. Remember, anytime you have just a number with no power, it is assumed and understood that it's to the first power. So this is going to be 3 to the 1 plus 10, which is 3 to the 11th. And then we can copy that from the what the actual number value is from the table of powers, which is 177,147. Okay, skipping down just a little bit, looking at 7c, we have 243 times 19,683. So what we need to do in this case is look at the table of powers. What power of 3 is 243? In the table of powers, we can see that that is 3 to the 5th. And then what power of 3 is 19,683? That is 3 to the 9th. So if we take 3 to the 5th and multiply it by 3 to the 9th, we're still going to have 3 as our base, and we're going to add our exponents to get our final exponent. So it's going to be 3 to the 5 plus 9. So that is 3 to the 14th power. And when we look that up in the table of powers, that is a ridiculously huge number, 4,782,969. So that's the way that number 7 works, and number 14 is just like number 7. And that for number 14, you will be using a table of powers for 4. Okay, so next we are going to move on to looking at number 8. Number 8 is just like number 15. You need to find the products and express the answer in scientific notation. So looking at part A, we have 2 times 10 to the 3rd multiplied by 4 times 10 to the 5th. Start by multiplying our numbers. 2 times 4 is 8. And then we have 10 to the 3rd times 10 to the 5th. That's multiplying numbers with exponents that have the same base. So we're going to copy down our base, which is 10. And then our exponent is going to be the sum of the exponents. So it's 10 to the 3 plus 5. So that means 8 times 10 to the 8th. And that's our final answer. It's already in scientific notation. Okay, so we're going to skip down and look at part C now. Part C has 5 times 10 to the 4th multiplied by 8 times 10 to the 7th. So we start off by multiplying our numbers. 5 times 8 is 40. And then we're going to multiply our powers of 10. We have 10 to the 4th times 10 to the 7th. So this is going to be 10 to the 4 plus 7. 4 plus 7 is 11. Now this is not in scientific notation. Scientific notation, you always have a number that is between 0 and 10. It cannot be 0, it cannot be 10, it has to be between 0 and 10. So where we're going to want to put our decimal is after the first non-zero number, which means right here after the 4. So we want to change this to 4 times 10 to some power. Now what power is it? To go from 4 to 40, we have to move our decimal one place to the right. So that's in the plus direction. So we need to add 1 to our exponent here, and it changes from 11 to 12. You can, if you want, go ahead and write out the actual decimal number for this one. We have 40. And then we need to add 11 decimal spaces. So that's going to be adding 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we can go back here and put our commas in so we can see what kind of number we have here. And then you can see that this is going to be equals 4 times 10 to the 12th, because we have a 4 followed by 3, 6, 9, 12 zeros. Okay, so let's move down and do part D. Part D is 3 times 10 squared multiplied by 7 times 10 to the 12th. 3 times 7 is 21. And then we're going to multiply our powers of 10. We have 10 squared times 10 to the 12th. That means we add the exponents. 2 plus 12 is 14. So we have 21 times 10 to the 14. We need to write this in scientific notation, which means we're going to put the decimal right after the 2. So that's going to be 2.1 times 10 to what power? Well, to go from 2.1 back to what we started with, 21, we have to move the decimal one place to the right, which means we need to make our exponent bigger by 1. So it's going to be 2.1 times 10 to the 15th. And so now this was number 8, which is just like number 15. And then I want to make sure we get a chance to go over the other two. So numbers 9 and 10 are just like numbers 16 and 17. In number 9, it says there are approximately 3 times 10 to the 18th atoms in 1 milligram of gold. So that equals 1 milligram of gold. And it says that 1 kilogram of gold is equal to 1,000 milligrams of gold. And then the problem asks for part A, how many atoms are in a kilogram? Well, if there's 3 times 10 to the 18th atoms in 1 milligram, and instead of 1 milligram, we have 1,000 milligrams, that means we have 1,000 times as much. So part A is 3 times 10 to the 18th times 1,000. So that's going to be 3,000 times 10 to the 18th. To put that in scientific notation, we would need to put our decimal right after the 3. So this would be 3 times 10 to what power? Well, to get from 3 back to 3,000, we need to move our decimal 3 places to the right. So we add 3 to the 18, which is going to be 21. 3 times 10 to the 21. For part B, it says write the number in decimal form. So we're going to write a 3 with 21 zeros after it. I'm not going to write all that out, but you can do that. Write a 3 with 21 zeros after it. Okay, number 10, real quickly. In 1 year, the Earth travels 584 million miles in its orbit around the sun. 584 million is this. And then you have to write that in scientific notation. And then the Earth has existed for 4.6 billion years. And you have to write that in scientific notation. So this first number is 5.84 because we move our decimal to right after the first non-zero number. And then we have to add 8 we have to move 8 decimal places to get back to what we had. 4.6 billion, that's 4 billion 600 million. We're going to move our we're going to put our decimal right after the 4. So it's 4.6 times 10 to the 9th. And that is all for the summary for Jacob's Chapter 8, Lesson 2. Hopefully that was helpful.